Now I'm going to check to see if precipitation is occurring in this system. So to do that, I'm going to calculate the Q value of this um, of this system, and then I'll compare it with the K, or the equilibrium constant. So we want to see whether or not precipitation is occurring. So first of all, I have the KSO or solubility reaction for ferric hydroxide, which looks like this. I have ferric hydroxide, and it's a solid, and it can dissociate into ferric and 3 hydroxides. And the KSO for this is 10 to the minus 38. So I'm going to solve for a Q, and first I need my ferric concentration, which is alpha naught times CT, and I used a solver on Excel to get this, and I got 1.37 times 10 to the minus 6, and that's at pH of 3.98 right here. And so my hydroxide concentration is going to be 10 to the minus 10.07. So my Q, which is ferric times hydroxide cubed, will be 1.37 times 10 to the minus 6 times 10 to the minus 10.07 cubed, which gives me a value of 10 to the minus 3.07, which is higher than the KSO. So Q over K will be greater than 1, which means that if our Q is too high, the reaction will go backwards or to the left, proceeds left. That means that a precipitant and this basically invalidates our approach here. Approach invalid because the ferric hydroxide is forming, so our CT is no longer constant. So we have a loss of ferric iron in the system, and is not constant, and so our approach is invalid. So we need to redo this problem and include ferric hydroxide solid as a potential sink for that ferric. And so don't despair, this will be remedied, because in the next video series we're going to go over precipitation, which will allow us to include formation of solids in our problem solving. So stay tuned.